is the calculator that I'll use today. So it says you draw many samples of size 15 from a population that's normally distributed, mean 120, standard deviation 20. Normal distribution says we don't have any sample size issue. What are the values of the mean and standard deviation of the distribution of sample means? Well, guys, the mean of the distribution of the sample means is going to be the mean of the population that we're drawing from. Central limit theorem tells us that. The standard deviation of the sample means is going to be the standard deviation of the population we're drawing from divided by the square root of n. Well, the standard deviation of the distribution we're drawing from is 20, and our sample size is 15. So if we can put 20 divided by the square root of 15 in our calculator, which we should be able to do with no problem, we get 5.16. I'm going to just round this to... So I'm going to just think of this as 5.2. Okay? Now, because I know the next question that we have. So the next thing is to sketch the distribution of the sample means using the 68, 95, 99.7% rule when n is equal to 15. Be able to indicate 1, 2, and 3 standard deviations above. Alright, so this is going to be pretty cool. Well, I don't know about cool, but it's going to be easy. So do your best at drawing a normal distribution. So smack dab in the center is going to be the mean, which is 120. And then one standard deviation above the mean is going to be add 5.2. Add another 25.2. And add another, well, I say 25.2, 5.2. Add another 5.2. All right, come on this end and subtract a 5.2. So that'd be 114.8. And subtract another 5.2. I think that's 109.6 if my mental arithmetic is correct, which usually it isn't. And then subtract another 5.2, and that should be 104.4. So gang, if we start with a population that's normally distributed with a mean of 120, standard deviation of 20, and we start drawing samples from that population of size 15, the mean and the standard deviation will be 120 and 5.2. Using that information, we can sketch this so we can see that 68% of the samples that we draw from that distribution will be between 114.8 and 125.2. 95% of the sample means will be between 109.6 and 130.4. 99.7% of the means will be between 104.4 and 135.6. It will be really rare, only 0.15%, which again, think of that, that's only 15 out of 10,000. So only 15 out of every 10,000 samples that you draw will result in a sample mean of 135.6 or higher. Same thing down in this tail. It's going to be really rare to get a sample mean of 104.4 or lower. Most of the sample means that we get, 95% of them, will be between 109.6 and 130.4. Now the next thing was the probability that one of these randomly selected samples of size 15 has sample mean above 132. Well guys, 132 is going to be about right here someplace. So I want to know the probability that's above, so that's equivalent to finding the area under the curve right of that. So guys, that's going to be a easy problem to do with your calculator. Go second function distribution, normal CDF. So we want above, what was it, 132? Yeah. 132 up to E99. Our mean is 120. And our standard deviation is 20 divided by the square root of 15. So the answer would be 0.0101. So this right here, this fourth, we usually report probabilities to 4 places. This 0 here is going to bump up to a 1 because the next number over here is 5 or bigger. So 0.0101 gives us our answer. Now 0.0101 just tells you that's about 1 out of every 100 samples. So it's not going to be very likely to get a sample mean of 132 or higher. Now the next thing says calculate and interpret the z-score for a sample mean of 150 sample size. Now 150 is way out here. So we're expecting the z-score to be very, very high because the z-score for 125.2 would be 1, and the z-score for 130.4 would be 2, and the z-score for 135.6 would be 3. Well, we got a long way to go before we get out to sample mean of 150. So let's go ahead and calculate it. So we take the mean minus we take the sample mean that we're calculating the. I'll tell you what, guys, this is a little blurry. Let me. All right, let's see if that helps a little bit. So now we're going to take the mean of the population. And then we're going to take the standard deviation of the population divided by the square root of the sample size. And I put that in parentheses and brackets just because it'll be easier for you to get the right answer if you do that, okay, in your calculator. So 150 minus 120 divided by, so we have the standard deviation, which is 20, divided by the square root of the sample size. And guys, make sure you got everything right here. Make sure all the parentheses are there. Make sure you got your division sign there. And make sure that this denominator, the denominator is in parentheses. So this is 5.81 standard errors above the mean. And we knew it would be just by looking at the picture. So guys, this answer here would be 5.81. That'd be the z-score. But I also asked you to interpret it. So we would say that a sample mean of 150 when n is equal to 15 is 5.81 standard errors above the mean. Very similar to just a standard z-score interpretation. But the only difference is because this sample mean is dependent on the sample, because it's used in the calculation, we have to report that in the interpretation. Okay? All right, guys, number 2. You draw many, many samples of size 40 from a negatively skewed distribution. All right, negatively skewed distribution, what should you think? Sample size. All right, because for these, it'd be really cool if you could see what I was writing. In a negatively and positively skewed distribution, we have to have sample size bigger than 30. So setting n equal 40, all right, that's cool. So it's bigger than 30. What's the mean in the standard deviation? So guys, again, mu sub x bar is just the mean of the population, which in this case is 25. And sigma sub x bar is just the standard deviation of the population divided by the square root of the sample size, which is 40. So 3.5 divided by the square root of 40 gives us 0.5534. Now, the reason I went to 4 places here is typically standard error you do. Last time I only went to 2 places, well, actually 1 place in the end, because I knew I was going to draw that picture and I didn't want to, add stuff. Heck, I had a hard enough time 5.2. Now, what's the probability that one of these randomly selected samples of size n equal 40 has sample mean below 22.5? Guys, 22.5 is about right there. Remember, 25 is in the middle. So 22.5 is everything to the left of that, so I know I start with negative infinity. All right? So let's work it. So negative infinity up to 22.5 with a mean of 25. Standard deviation 3.5, but we got to divide it out by the square root of the sample size, which is 40. Now again, remember, probabilities between 0 and 1. So right off the bat, you look at this and a red flag should come up and you should hear Darbro screaming at you at the top of my lungs. Probability has to be between 0 and 1. It can't be 3 point. So you look out here and you see you've got scientific notation, which says, again, we've got to take this decimal point and move it 6 places to the left. The first time we move it gets beyond the number, 3 in this case. The other numbers, which will be 1 less than that, which is 5, gives me my zeros. So guys, I know I'm going to have 5 zeros. Doesn't take too long to draw it. And put in a couple of numbers or whatever, 0.31. All right, throwing you a little bit of a curveball on this one. What's sample mean? Now, guys, this is, this isn't asking a probability, proportion, percentage, anything like that. It's not. So we're not going to use the P key. We're not going to use that normal CDF. What we're asking here is we've got this normal distribution, which we know has a mean of 25 and a standard deviation of 3.5 over the square root of 40. We're asking which one of these represents the 33rd percentile. So guys, there's some sample mean right there that has 33% of all the other sample means below it. Well guys, we should know by now that the inverse norm key is the key that works these types of problems. And the inverse norm key requires you to put in 3 things. Percent below is a decimal, the mean, and a standard deviation. So put that in our calculator. Life is good. I don't know if life is good, but so 0.33, comma 25, and then put the standard deviation is, guys. It is so tempting to put 3.5 and stop. But remember, central limit theorem, you got to come in and divide by the square root of the sample size, which is 40. So guys, the sample mean would be 24.76. So we knew back here that it was going to be a value below 25 because the mean is at the 50th percentile because it has 50% of the scores below it. So this mean right here that has 33%, we knew it had to be to the left of 25, but we didn't know how far to the left. Well, it turns out it's 24.76. All right. All right, teacher salaries at a very large school district are positively skewed. Again, positively skewed is critical here because that means that we've got to have sample size 30 or bigger to work the problem. So has a mean of 65,000, standard deviation 15,000. Describe the shape, center, and spread of the distribution of sample means when drawn 15 at a time. Well, that 15 is not bigger than 30. So we can't do that. I mean, you got to take that sample size restriction literally and seriously. It's got to be 30 or bigger. We can't work with that. Yeah, once the sample size gets 30 or bigger, we know that the shape will be a normal distribution. We know that the center will be the mean, and that's the mean of the original population. And we know that the standard deviation will be the standard deviation of the original population divided by the square root of the sample size, which is 75. All right, so I'm going to put that just quickly. I'm not going to show you the operation because that's pretty simple. So I get 1732.05. All right, let me just show you the way that I type that in to make sure everybody's okay. All right, cool. So 75 teachers are selected at random. That's important. Otherwise, we can't calculate probability. So what's the probability of their average salaries between 62,000 and 64,000? Well, that's a classic normal CDF problem. We're looking at probability. Starts with a P. So what do we want between 62,000 and 64,000? With a mean of 65,000 and a standard deviation of 15,000 divided by the square root. I don't have my glasses on this morning, guys. That's kind of crazy. Square root of 75. 0.2402 is going to be the answer to this problem. Guys, y'all should be getting pretty good at this stuff. All right, what's sample means? So guys, again, like we did before, we're going to use inverse norm. 95th percentile is 95% below. So we're going to have inverse norm. Percent below. Our mean. And our standard deviation. Guys, if you want to get these problems wrong, then don't put that divide by the square root of the sample size. You'll get it wrong every time, and that's not the purpose. We want to get these things right. All right, 75. So guys, there's what I get. So 67,848.97. Kind of really disappointed with Hawks in a way that they don't have problems like this. They don't have problems for Z-scores. So I'm really disappointed in some of the problem sets that Hawks has. And everybody keeps telling me, Darby, you need to write you a statistics book. And I've thought about it, but I tell you, with as busy as we are in our lives, it's just hard to find a time. You know, I'm picking up another doctoral dissertation student. I'm meeting with her tomorrow, so I'm probably going to be on her committee. So that bumps me up to 3 now, and there's even a possibility of 4. And I'm advisor for 3 master's thesis students, or groups of students. Involved in 2 major grants and teaching and director of graduate studies. It's just well, of the graduate program. It's hard. So. That's my complaining for the day, so sorry. All right, gang, let's do the Z-score. So for a sample mean of 70,000, Just like always, subtract the mean. Divide out by the standard deviation. But since this is a mean, we have to divide by the square root of the sample size, which is 75. Now, gang, by now we should know that you've got to appreciate the parentheses. So I'm going to put the numerator in parentheses. Minus the mean. Divided by, put the denominator in parentheses. Divided by the square root of 75. All right, so 2.89. Now in class, I wouldn't be this fast. I would, you know, be a little slower. But guys, y'all have access to that pause button. So if you need to see how I put that in a calculator, you can pause. So just like before, there's not going to be anything different. And you can look back at your notes, which you should have taken. You just say that a sample mean is 70,000 when the sample size is 75. Is 2.89 standard errors above the mean. So guys, we can learn from the past.